Hello, the topic is about Bluetooth, and this is Group 17. My name is Li Hailin. First, we begin at what is Bluetooth. Bluetooth is a wireless technology based on the IEEE 802.15.1 standard. It was invented by Ericsson in 1994 and was named after the Danish king Harald Bluetooth. It operates in unlicensed 2.4 GHz to 2.485 GHz ISM band. It uses frequency hopping spread spectrum called FHSS technology to transmit signals across different channels with a channel spacing of 1 MHz. Bluetooth is mainly used for wireless personal area network, enabling devices such as mobile phones, tablets, and headsets to exchange information without the need of cables. The connection process of Bluetooth contains three parts. When two devices come into close range, they first enter the device discovery phase, called inquiry. One device, such as A, broadcasts a query, and nearby devices, B, in listening mode. They use their unique 48-bit address to allow mutual identification. After inquiry, they come into pairing. During pairing, both devices exchange key information, such as address, name, profiles, and keys. Once successfully authenticated, the devices establish a bond that allows them to automatically reconnect. Devices are successfully pairing. They come into paging. During paging, the roles of master and slave are assigned. The initiating device typically becoming the master, and the responding device joining as a slave. Ultimately, all connected devices form a piconet. Each piconet consists of up to 8 devices. Multiple piconets can coexist in the same area by employing different frequency hopping sequences in the shared spectrum, thereby forming a scatternet. Bluetooth contains several protocol layers to achieve its function. Unlike the traditional OSI 7-layer model, the Bluetooth protocol stack don't need a central controller. The Bluetooth protocol stack mainly consists of 6 parts. The lowest layer is radio layer. It defines RF characteristics and uses FHSS to reduce interference. The second layer is baseband. It handles device discovery, connection establishment, role assignment, packet handling, error correction, and encryption. The third layer is link manager. It manages link between the master and other devices using the link manager protocol. L2CAP layer provides an interface between upper layer protocols and lower transport layers. HCI layer allows the host processor's software to communicate with Bluetooth hardware. The top layer contains several protocols. It supporting protocols such as RFCOMM, along with legacy protocols like PPP and TCP/IP. The Bluetooth physical layer primarily employs 3 modulation techniques: GFSK, pi/4 DQPSK, and 8DPSK. GFSK used in both Bluetooth Classic and Bluetooth Low Energy. The data rate is typically around 1 Mbps, suitable for low data rate transmission. It's fundamentally ideal is to introduce a Gaussian filter to smooth the digital data to ensure continuous phase and reduce interference. Let's DT represents the original digital data stream, which passes through a Gaussian filter with impulse response, GT. The filter signal is expressed as MT. The design parameter of the Gaussian filter is usually measured by the bandwidth time product. Lower BT value may lead to increased inter-symbol interference. Conversely, a higher BT value reduces ISI but broadens the signal spectrum. The filter signal's MT is then multiplied by a modulation index and converted into a phase change. The modulation index H, typically around 0.5 in Bluetooth. The modulation index determines the frequency deviation. Finally, the phase module signal is expressed like SST. For higher data rates, Bluetooth Classic adopts differential modulation, pi/4 DQPSK, with data rate 2 Mbps. Unlike GFSK, pi/4 DQPSK uses differential encoding to transmit data. It transmits the phase difference between successive symbols rather than the absolute phase. Phi k-1 is the phase of the previous symbol, and the current symbol's data is represented by the phase difference. The set of allowed phase differences is constrained within pi, and the phase modulation signal ST is the same as the GFSK. DPSK is another differential modulation technique used in Bluetooth enhanced data rates and achieve higher data of 3 Mbps. Similarly to pi/4 DQPSK, 8DPSK use the phase difference between successive symbols to encode data. The set of allowed phase differences is expressed as this equation. To ensure that the phase values remain within the range 0 to 2 pi, a module 2 pi operation is applied. ADPSK allows each symbol to transmit more information, but demands better channel conditions and a higher signal-to-noise ratio. In 1994 to nowadays, Bluetooth updates 5 versions. The initial versions, Bluetooth 1, achieve around 1 Mbps data rates with a range of about 10 meters. In the second version, it introduced enhanced data rate with differential modulation, increasing data rates to 2 to 3 Mbps with a range of about 20 meters. When it comes to Bluetooth 3, it added an optional high-speed module leveraging IEEE 802.11 technology, boosting data rates up to 24 Mbps. In the Bluetooth 4, launched in 2009 with Bluetooth Low Energy, focusing on ultra-low power consumption and extending communication range to 16 meters. In Bluetooth 5, the newest version enhanced low energy up to 2 Mbps and introduced new features such as improved indoor positioning. Future prospects of Bluetooth include enhanced indoor positional using RSSI, AOA, and AOD, as well as mesh network for large-scale connectivity. Thank you.